Hello everyone. Today we're going to learn about the difference between balanced cables and unbalanced cables. So let's start out with unbalanced. So that's here your RCA cables, your 1/4 inch, all that kind of stuff. So inside these cables, let's draw a little diagram. So let's say I have an audio signal. Okay, I'll draw some notes here. Some really sloppy looking notes. I have an audio signal and that is going into one end of this cable. Okay, and then I have two wires inside this cable, and then it goes to the other end. So the first wire actually carries the sound. So I'll draw a little waveform here for the sound. Okay, something like that. So that is what would be on the tip of the cable here. The sound goes through that wire. Then you also have the sleeve, the long cylinder here. The sleeve is the ground, so that just conducts the electricity and also brings signals back the other direction, but it doesn't actually carry the audio signal. So that's just the ground. Also provides some insulation. You have some insulation in the cable here, but mainly you've got one wire that's carrying your audio signal. Okay, so this wire, let's demonstrate. So let's switch over here. Okay, so I've put together some audio files that will demonstrate what this sounds like. So if I'm just sending an audio signal through the cable, it will sound something like this. Okay, so that's the raw audio just going into the cable. Problem is, these cables act like antenna. Okay, the wire inside of them acts like an antenna, so it is going to pick up noise. Where did my mouse go here? There it is. So there's two ways that it gets noise. One is from radio frequencies. Okay, radio frequencies come through the insulation of the cable, and it can interfere with your audio signal. You can also get noise from magnetic interference. So if you've got magnetic coils, this could be coming through power cables. If there's power cables near your audio lines, it could come from fluorescent lights. All kinds of things could cause this. So all of these things are going to add. So let's say we have audio, and then we also have plus noise. Okay, so that means, and the noise is being picked up on the cable, right? It doesn't go into it. This is just the guitar sound or whatever. The noise gets picked up through the cable. So then by the time you get to the end, you will have audio plus noise, and it will sound like this. Okay, so obviously this is unusable. The noise is so loud. It's not always going to be that loud. Sometimes it's barely distinguishable, but sometimes it can be really annoying. Sometimes it can actually pick up radio frequencies, and you'll start playing the radio station through your amp. But this, just as a demonstration, this is what it sounds like with, I've just generated this noise and put it in there. Okay, so let's print this to a new track. Right now I have them combined in this bus that I'm calling wire 1. So I'm going to go here, bounce to a new track, select a track. Okay, so this is our audio from wire 1. Alright, so if I just solo that, this is our guitar sound plus the noise. Okay, so when you're using an unbalanced cable, let's go back to flash here, unbalanced cable like these, this is potentially what you could have. There's always going to be some noise, not necessarily that bad, but you will have audio plus noise. Now here's the advantage of balanced cables. Just like your your XLR cables over here. Oh, where are we? Tried to zoom in. No. I don't know. Okay, so XLR cables are what's called balanced. So here's the difference. All right, we've got our same audio signal going in. Okay, so here's our little notes. And that goes into the end of our cable. But here's what's special about this. Once it goes into the cable, notice how the XLRs have three prongs. So that means they have two wires that carry the signal and then one ground. So in these two wires, your signal gets split in half. Not in half, but doubled. So it gets split, and the one wire carries the positive signal. So we'll call this audio positive. The other wire gets the exact same symbol, but it is reversed. So it is flipped 180 degrees out of phase. So as an example, here's our wave going through here. Okay, notice how this one, it starts going up and then goes down. This one is the exact negative image of that, so it goes like this. Okay, and then well, let's demonstrate this first. So we know, if you've learned anything about phase in waves, if you have something that's exactly opposite, 180 degrees opposite, it will cancel itself out. So even though there is noise, or not, even though there is, a signal going through here, when they're combined, you can't hear anything. So let's demonstrate that. Okay, so here I have just this guitar signal, and here I have the exact same guitar signal, but see on this little button right here, this button means polarity reverse, so it is 180 degrees out of phase. So if I play just these two, nothing. You can see there's still volume in the individual tracks right here, but see if I turn one of them off, or I turn the other one off, but when they're combined, there is nothing. Okay, so that's the first step of these balanced cables, is it flips the signal 180 degrees. So now both of these wires are going to pick up noise, just like this first one did. Okay, so we still have the same sources of noise. We've got radio frequencies. Okay, and we've got magnets. Oh, and also we have our ground wire that comes through here. Okay. Okay, so we're still going to pick up noise on both of the wires now. Okay, so and in this case, I'm going to call it, this is going to sound really goofy, I'm going to call it moise with an M. Moise. Okay. So both of these wires are going to pick up some moise. Now let's hear what this is going to sound like. Alright, so let's add, here's the noise that's combined on, well, yeah, okay. So here's the guitar signal with the noise. Here's the other guitar signal with the noise. Now look how loud that noise is, right? So both wires are picking up the exact same noise, and since there's two of them, the noise is doubled. But because because the polarity is reversed on the audio, we're not hearing the guitar at all, we're just hearing double the noise. Okay, if that's how it was, then you'd never use these cables. But here's the genius behind it. Once it gets to the end of the cable, Here's the end of it. These are combined again, and this wire is switched back 180 degrees. So when it comes in, now this negative audio has flipped back to positive. Okay, so now we have A2A positive, and our noise, right? Our noise has been flipped upside down to woise. So now the two noises are going to cancel each other out. Okay, let's write a little equation down here. So we have audio plus noise minus negative audio plus noise. Okay, that's our equation, because when it gets here to the end, where are we? When it gets here to the end, it's flipped. So it's all turned the opposite way. So that makes equals, go to our paintbrush, equals, I'm about out of room here, equals 2A and 0 noise. They cancel each other out. So let's see what this sounds like. Okay, so I've printed this one. Let's here's my bus that both of these signals are being sent to. So let's print this. Bounce to new track. Okay, so here is audio from wire 2. Okay, now I'm going to hit this button right here, Polarity Reverse. Okay, and let's turn off all these solos. Oops. And let's just move these down so they're next to each other. Okay, so here's what we're dealing with. We've got audio from wire 1, audio from wire 2, and wire 2 has been inverted at the end of the cable. Now this is what it sounds like. How about that? So the noise is completely gone because it has reversed upon itself, and your audio signal has actually been doubled. So that is the beauty of XLR cables. Now, a couple of advantages of using XLR cables. One is that they have no noise. Oh, let's write it down here. No noise. Also, they have an indefinite length. You can run these cables for 100 feet, 1,000 feet. Their signal, you're not going to have a loss of signal. So that is why they're used for microphones and that kind of thing, because you can boost the signal and still get no noise in it. So hope you've learned some stuff about balanced cables, and we will see you next time.